Good afternoon,
conference
everyone.
will now be recorded.
So, yes, good afternoon, everyone. My name is Melanie Denley, and I'm Programme Engineering Manager with the Asset Enhancement Team within the Network Rail Technical Authority. I've been working on European projects for the past 3 years, initially with the project IN2TRACK, and then moving on to the follow-on project, which is the current IN2TRACK2 project that we'll be talking about later. And I'm leading the next generation track work package within IN2TRACK2. So together with my colleague Phil Winship, I'll present some of the work carried out in the UK as part of the IN2TRACK2 project. But first, I'll give an overview of the project, and then some of the work being carried out in the UK for plain line applications. And Phil will continue and present the UK S&C work. So I'll just turn my screen off so that go through the slides. Okay, so if we start on the next slide, IN2TRACK2 is one of the projects within the Shifter Rail programme. And I'd like to say a little bit about Shifter Rail for those who are not too familiar with the programme. It's a collaborative European research and development programme, and it's looking around the integration of new technologies into innovative rail solutions, and looks at research and development from a whole system perspective. And the main aims are to increase capacity and reliability significantly, whilst reducing life cycle cost. And as such, it aligns very closely with the UK Rail Technical Strategy functional priorities. Shifter Rail brings together industry partners to deliver the R&D in the 5 innovation programs you can see there. So that's IP1, which is all about cost efficient and reliable trains, IP2, management control systems, IP4, which is the railway services, as you see stations there, and IP5 is all about freight. Today we're focusing on IP3, which is where the IN2TRACK2 project sits, and IP3 is all to deliver innovative solutions for cost-efficient and reliable high-capacity infrastructure. And the main aim is to deliver integrated system demonstrators up to TRL7, which is in the operational demonstration in the operation environment. And as I say, looking at treating it as a whole system. So there are 15 projects within IP3. Some of them are shown here, which is a timeline sort of from left to right. And the first project, starting with the first project, which was the Interrail project, which looked at innovative intelligent rail. And it was a lighthouse project started in 2015. And really it was to test the concept and provide the preliminary input to the Shift Rail work. The work relating to track and S&C continued in the 3, has been continued in the 3 IN2TRACK projects, of which IN2TRACK2 is clearly the second. And Network Rail is the main partner in all 3 of those projects. There are 2 other separate projects shown there which relate to track and S&C. And they are closely linked with the work that we're undertaking in the IN2TRACK2 project. That's S-Code, which looked at innovative concepts for next generation S&C. And the results of that feed into the IN2TRACK2 work that Phil will mention later on. There's also a project that's just started, which is Interzone. And that also, it's a separate project looking at next generation transition zones. So obviously it's closely aligned with the work that we're doing, some of the work we're doing in IN2TRACK2. So we're also working collaboratively with InterSmart, which finished last year and has gone on to the follow-on project InterSmart2. And I'll say a little bit more about that later. So Shift2Rail is all about working towards higher technology readiness levels, TRLs. Currently, the work we're doing is round about TRL 3 to 5, somewhere there. So proof of concept at TRL 3, up to starting to demonstrate the prototypes and technologies, or rather validate them in relevant environments. But the aim, obviously, across Shift2Rail is to get up to 5 to 7 by the end of Shift2Rail. So demonstrating in a relevant or operational environment. In the UK, we also look at rail industry readiness levels as part of our development process. And this is focusing on whether the technology that we're developing is ready for use in the railway industry. So it's looking at a range of areas, such as reliability and integration with other systems. Again, looking at it as a whole system approach. So turning to the IN2TRACK2 project itself. This is a €13 million project, which Network Rail is coordinating, and Network Rail is also a major partner in the consortium that is delivering it. And the consortium consists of 28 partners, infrastructure managers, manufacturers, universities, and research organisations across Europe. The project was started in November 2018. And it's due to finish in November this year. So it's still very much work in progress, still. And the aim is to work towards the delivery of the global Shift2Rail objectives, which, as I said, is all around reliability, increasing the capacity on the network, and lower life cycle cost, towards delivery of the TRL7 demonstrators by the end of Shift2Rail. The project consists of 5 technical work packages. There's 2 S&C and 2 in plain line, and there's also 1 work package that's looking at structures, tunnels and bridges. But focusing on the S&C and plain line track aspects, these in turn are also split into 2 work packages each. So we've got the enhanced and optimized S&C track system. So that's enhancing and optimizing what's there at the moment, the existing using new technologies to enhance what's there at the moment, to contribute towards those Shift2Rail objectives. The next generation S&C and plain line is looking at 40 years beyond current state of the art, and so introducing technologies to achieve a step change in performance. And Network Rail are involved in all of these work packages, and we're also leading work package 2 and 4, which are the next generation work packages. So we have over 40 individual work streams relating to track and S&C in the work that is being done in the UK within IN2TRACK2. And it's obviously our partners within IN2TRACK2 are delivering very many more. So it is a very big project. So just looking at the main areas of research and development within IN2TRACK2, we've just look at we're on the next slide. We have this slide shows sort of the main areas, and Network Rail is involved in all of these to one way or another, in collaboration with our linked third-party universities and organisations which are carrying out a majority of the work. So just sort of going around there clockwise, we have track drainage. We've got 3 pieces of work in there, looking at materials, and we've done some horizon scanning and future concepts. Track system substructure, we do have some work in that, although the majority of work is being delivered in there with our European partners. Noise and vibration, a couple of pieces of work, one on looking at rail roughness growth rate, and another at a novel method of rail shielding. And then we've got autonomous inspection and repair, which I will say a bit more about the work within for plain line track in a moment, together with track SNC maintenance, monitoring and sensing systems. And then we've also got a piece of work around digital twin, which we're working in collaboration with our European partners. And just to say probably a few words about digital twin. So this is a virtual representation of a track and SNC system. So it's this sort of digitized version, but it aims to bring all data sources together, and it links into things like simulation models, predictive tools, etc. And the aim is to assist in decision making and also sort of visualization of the asset. So beyond that, we have S&C work in kinematic systems, and also we've got quite a bit of work in design materials and components. Phil will talk about those kinematic systems and design materials and components that relate to S&C later, together with the S&C related work streams in autonomous inspection and repair, track and S&C maintenance, and the monitoring. So, first of all, I will give a high-level overview of 5 of the plain line track related work streams. So, in the area of autonomous inspection and repair, we have autonomous ultrasonic rail inspection and automated rail defect repair, DDR. In track and SC maintenance, we have some work looking at rail stressing. And in monitoring and sensing systems, there's some work being done on thermal rail stress measurement and track stiffness monitoring. So first, the autonomous inspection repair. So this is common across both track and S&C, and the diagram depicts the overall concept. So it shows the different inspection repair processes, feeding data in and out of sort of a central database. And so clearly it links to the concept of digital twin that I mentioned earlier. So we have several inspection processes shown there. Some obviously are recognisable as current methods, where we have visual inspection, and also train-borne monitoring via, for example, the NMT, UTU, etc. Although there is also train-borne monitoring is one of the aspects of the work that is being done within IN2TRACK2, both by ourselves and also in the UK, but also in other projects or other work streams carried out by our European partners. One that you may not have seen before, that's something that is being looked at for S&C, is the concept of unmanned aerial vehicle operation, which or otherwise called drone inspection, which Phil will mention in more detail later. And then at the bottom left, we have the autonomous robotic platform. So this is sort of a concept for autonomous inspection and repair, which I will talk about in a moment. So that particular process sort of feeds into, has an interface, but all of the sort of inspection reports, if you like, the data from the inspections feed into the central database, and the idea obviously is then to feed the information back to actually carry out the work. And part of the sort of the concept of autonomous inspection repair is that that will potentially be a inspection vehicle, and maybe another separate vehicle or something along those lines to actually carry out the repair. And again, we'll talk about that in a moment. On the right there, we also have data analytics. Of course, we're collecting all this data, and that can be used and is being used for analytics. Currently, in a separate UK project, which is looking at the data decision support tool, but also within IN2TRACK2, we have a number of work streams looking at data analytics for predictive capability, etc. So, first of all, mention the autonomous inspection. So one of the pieces of work that Cranfield are working on, the University of Cranfield, is autonomous ultrasonic rail inspection. And this is a project that is IN2TRACK2 is working with the InterSmart2, the other shift-to-rail project, InterSmart2, that I mentioned earlier. And the InterSmart2 are preparing or developing the command and control system for the robotic platform, whereas the InterTrack2 are looking at the actual inspection itself. So within the within this project, the trolley to mount the which is a road vehicle, road wheeled vehicle, so that we can be mounted on the track. With Cranfield have produced or developed that trolley, and what's currently being done is that the ultrasonic probes are being fitted to that autonomous vehicle, so that the concept is that the vehicle will be given the instruction to travel along the track, as shown in the diagram there, and it will be the ultrasonically testing the rail, and that is current technology, ultrasonic technology, and obviously, and once if it finds a defect, and defects are artificial rail defects are being put in the piece of test track that this will be demonstrated on, and once it's found the defect, it will stop and transfer that data across to the autonomous vehicle, which has the positional information, and then a report will be transmitted from that. That's the concept at the moment. As I said, it's currently being developed, but the plan is to demonstrate this concept in IN2TRACK2. So I mentioned that, that the concept was to look at inspection and repair. And in IN2TRACK2, there are several methods of particularly rail repair, but also others as well, that have the potential to form part of an autonomous repair inspection repair system. This is one of them. This is the one that's being developed in the UK. DDR, discrete defect repair of rail. It's a project, it's a piece of work that was started in IN2TRACK2, sorry, InterRail, and it's an innovative solution for the in situ repair of rail defects, railhead defects such as squats and whale burns that you see there, using a low heat process. And it's now fully automated process, following the positioning over the defect. So let's just look at how it does that. So all the automated parts of this, it clamps to the rail once it's over the rail, and then uses latest profile measurement for the precise measurement for the processes that follow, which is the excavation by milling and weld restoration, and then followed by reprofiling. Now, the reprofiling is by milling. This is one of the first ones that was done, and there is still work ongoing to develop that, and it's all under PLC control. So another area of development is a novel method of rail stressing by using the induction technique. This is an extension of the current separate UK project developing induction welding. But the part that it was being looked at in IN2TRACK2 is to look at the concept and of doing that with using the induction to stress rail. And the benefit of this is that potentially it has the potential to be able to heat the rail, stress it without the needing to cut it, as it forges, it heats the rail and forges it, as you can see there. And the concept was demonstrated. You see the process just after it's been the excess has been or the upset has been stripped off on the bottom photo there, and the piece of rail that did the demonstration at the top. Very good bend test results, which match those of the pre-forged rail. So that was very good results. Having said that, the test specimen is being sent to for the macro testing, which to confirm the weld quality, which is being done at the moment. So those results are awaited. So staying with the subject of rail stress, whilst those stressing trials were underway, the opportunity was taken to combine a trial with field testing of a novel method of rail stress measurement that is being developed by the University of Sheffield. So clearly, obviously, measurement of rail stress is a key issue to prevent rail track buckling in hot weather, and we looked at alternative methods for doing so, which addresses a key Network Rail challenge statement. So, which helping to prioritise the work and minimise service disruption, and obviously support effective stress management. So Sheffield are developing this method, which is a device which you can see at the top right-hand photo there. And it uses a novel arrangement of ultrasonic transducers to determine the longitudinal rail stress by sending the ultrasonic waves through in this case, a test specimen that you see in the lab there. Now, obviously, because there was the opportunity to go out to test this in rail in the field, this has been done sooner than was originally planned. So, which was useful to actually coordinate and collaborate those two work streams. The promising results in the lab. We're waiting on the results from the field tests. That's being analysed at the moment. Yeah, potentially it has the potential for an accurate, non-destructive method, and which for carrying out measurement of rail stress. So finally, in the pieces of work for plain line applications, there's a piece of work being done by teams within Network Rail in work package 3, that's the optimised track, on track stiffness monitoring. So this is a continuation of the previous UK project, which was carried out within Network Rail, which fitted accelerometers onto the NMT on 4 axle boxes. As you can see there, I don't know, on the red dot is on the power car, and on the blue dot on the right hand side is on the mess car. So power car being the heavy axle load, mess car being the light axle load. So this obviously tracks the measurement of track stiffness is loosely correlated with sort of track performance. But what the team are looking at is to look at how that relates to the track deterioration, which can then go on to enable proactive or preventative maintenance regime, which again will reduce service effective failures and potential to reduce whole life cost. So the work that's been done in the IN2TRACK2 is to continue that work, and also a piece of work to validate the work being done previously and ongoing is taking site measurements using a digital imaging DIC camera. And those results are looking promising, although we've only the team have only able to look at one site at the moment because of the restrictions over the past few months. But the aim of the project is to develop intervention thresholds for the rate of change of track stiffness, which is what is being looked at in here. And there's finite element simulations to investigate how that relates to track performance. So that's some of the work being carried out relating to plain line track. So I'd now like to hand you over to Phil to tell you more detail about the work that is being done in S&C. So thank you, Phil.
Thanks, Melanie. Good afternoon, everyone. For those who don't know me, my name is Phil Winship, obviously. I'm Principal Engineer in the Asset Enhancement team in the Technical Authority, so working in the same team as Melanie. And I've been working with the IN2TRACK2 project for about the last 2.5 years now. And prior to that, as quite a few of you probably know me from the S&C team for quite a number of years, in working in the S&C team within what was Safety Technical Engineering prior to Technical Authority. So yeah, looking at the IN2TRACK2 project, I'm the technical lead for Work Package 1's content that involves Network Rail. So in other words, projects where actually one either actually contributing to that task, that work package, sorry, or actually running some of the tasks that are actually in the work package. So just to recap on something Melanie mentioned earlier, work packages are, as it suggests, a package of work, but they're actually split into different tasks in the actual content of the work package. So it's probably typically around about 5 in each work package. And again, they're split again into subtasks further down. So some of the work that you see and what Melanie's talked about within her work package work are some contributions we make to the subtasks and the larger work as a task in relation to various different subtasks making up a complete subject, like autonomous inspection and repair, for example. And as for work package 2, which is the next generation switches and crossings work for IN2TRACK2, I'm the technical lead for that and the work package lead in terms of Network's contribution to that. So in front of you has just got the screen there showing a few of the projects I'll just talk about briefly. There are quite a lot more than these. These are just some of the highlights really to actually go through and give you a bit more of information about what type of work we're involved within Network Rail's contributions, and clearly looking at these in terms of looking towards trying to help with the challenge statements for switches and crossings in particular that Network Rail have in place. So obviously looking at inspection and repair, as mentioned before, I shall talk a bit about the potential for drone S&C inspection, looking at the crossing defect repair mechanisms, which is similar to the discrete defect repair system that I mentioned earlier, but they're obviously quite a bit different in terms of what the crossing needs. A little bit about some track and S&C maintenance activities, excuse me. Looking at additive manufacturing and looking at producing S&C components in the different way that we do at the moment. It's a handheld scanner, which is looking at taking a snapshot scan with a laser of a switch profile. And I'll talk about what that entails. Some optimization of NR56V crossing profiles, and then coating of switch rails, and that's looking at really seeing where we can actually improve the wear characteristics of our rails, in switch rails in particular, where we get lots of aggressive wear in switches in tight radius switch units, and in other areas where switches obviously see some great loading laterally to actually avoid, as where possible, the switches wearing away too quickly. So reducing the maintenance that we need to actually do on those. Looking a bit further down, monitoring and sensing, we've got a little piece of work going on looking at location identification for switches and crossings. And finally, a little bit about kinematic systems, and that means basically our point operating equipment and how that actually looks at conceptual designs of looking at the next generation, potentially from what's termed as repoint before. We're talking about a little bit of development further with the repoint system. So looking onto the autonomous inspection and repair, couldn't resist doing the flying with a drone. This is a Vogel drone, which is run by the company there that's mentioned at the top, Plough and Craven. They're one of our drone framework companies within Network Rail that we work with. There are 4 drone companies we can work with, but we've chosen this one really down to the fact that it's got a higher payload than the others that are capable of. And this drone has 8 rotors on it. You can see there's 4 wings there, but there's 2 rotors on each of those ends, and obviously that means it's got quite a lot of redundancy. So if one of those fails, it isn't really going to stop it from flying. It's going to be quite more robust at being able to cope with problems with any of the rotors actually failing. And the other thing that this has over and above some of the other drones that we can see are used on the infrastructure, it's got a 10-kilogram payload characteristics, which obviously means it can carry a bigger camera system, which means we can obviously improve the visual footage that we see from the drone. So on the picture there on the right hand side, you can see this is the feasibility study we did in December in 2019. We're looking at a piece of S&C in Progress Rail's yard at Beeston. And just looking really, it was flying this around the S&C unit just to find out at different heights what was physically visible and what actual footage we could see and what was clarity we could actually get from the actual component inspection perspective. So we've gone through various different iterations of this on that particular trial, and that's the sort of view you can get. And this was actually a piece of footage that was taken not on this particular set of S&C, because you can see it's on timber, which is obviously not the same picture, but this is the type of footage that you can actually see on the camera, which is from about 35 meters up. So from an inspection point of view for BVI, you can see all the componentry there quite clearly. But if we actually look at some footage, which I've not got a picture of here, where it's lower down, I think we went down to 11 meters as to the minimum height we did the test on. The footage is much clearer than that. And obviously that might mean we can actually pick out any defects, especially in rail terms, if there's any squats or anything like that on rail heads, or an S&C where we've got some potential cracks that might be apparent in the casting of the crossings here. So we've done quite a bit of work with reporting and what Plough and Craven's able to do with this drone. And the one thing we're looking next to do later this month is some more trials within the Voestalpine yard at Harworth, where they actually assemble S&C for us as well. And then go out to a site on track in Leicestershire, which we're just sorting out to actually do some real-time inspection of a piece of S&C out in the field. The one thing that this will actually help with in terms of moving further away from actually having to have boots on ballast is obviously doing basic visitor inspections, and there's potential then to look at supervised inspections, because the footage that this takes is obviously, it's a digital format. So the pixels that the picture's made of can be used to actually dimension between rails, for example. So it can take gauge dimensions. And we've got, obviously the capability of the software at the moment is limited to about sub 5 millimeters. So we need to get a little bit more accuracy in terms of what it's able to do with that. But that's something that we can work with the company Plough and Craven to actually look at software updates to actually improve that accuracy, so we can get this similar accuracy to what we have with a track gauge eventually. So that's the ultimate aim. So there's quite a lot of work, and it's quite exciting to work in this sense. And obviously within Network Rail, we've got quite a big project that's running outside of the IN2TRACK2, which is looking at workforce safety, led by Nick Millington. Now I've made him aware of what we're doing with this, and he's very keen to look at how we can work together to collaborate and make sure that we can incorporate this type of inspections into their particular processes for keeping people off track where we possibly can by supplementing S&C inspections by this method. So obviously there's quite a lot of potential for this to give us a lot more wider benefits than just actually inspecting S&C in a different way. And this is obviously something that we're trying to actually work with European partners to actually make sure we incorporate their needs as well as what we need for our particular requirements. So these are some of the actual footage off the CES site we did at Beeston, and you can see that is footage. Both of these were from the actual height of 35 meters. So one obviously is zoomed in quite clearly, but it's quite remarkable how much detail you can see on the actual drone pictures. So obviously it just gives you a feeling for what the actual capability of these cameras on these systems can achieve in terms of what we can look at. And obviously I think the bigger picture is looking from a point of view of PLPR. If we can use similar software from a drone footage point of view to actually look at pattern recognitions, we can actually incorporate similar types of technology into the software for the drone to actually make sure it can actually do the inspections for S&C very similar in terms of what PLPR does for us in plain line. Okay, moving on to autonomous repair. This is obviously quite a similar concept to what DDR showed in the previous slides that Melanie went through. And this is something that's been looked at in terms of purely for crossing, to try and look at defining where we can actually get the benefits of repairing a crossing. So at the moment, the feeling is that this is obviously a concept. They're going to start building this machine in the next few weeks to actually get something similar to what was shown by the slides that Melanie had for the DDR. But this is looking purposely around defining an area within the crossing wing rail that actually obviously sees the wheel transfer on a switch, or on a crossing unit, that sees the wear or sees damage through batter, for wheel impact loads, etc. To be able to mill out that area as a predefined particular area where we see that damage. And that's probably going to change in terms of the area itself for different crossing angles. We're probably going to have 2 different areas defined for a range of crossing angles, because obviously the larger crossings, the longer crossings are going to need a bigger area of milling to actually achieve that. So we can actually take out the defect, or we can actually excavate to a certain depth, so we can then deposit weld repair on the actual crossing wing rail or nose, bring those back up to where we need to from a design perspective in terms of either new or just being able to blend it into something similar to the wear on either side of the wing rail and crossing nose, to really repair it in a much better and controlled manner than we do at the moment. The other advantage of this is some of the work that's been going on in the background with the developments of this is looking at potentially repairing a crossing with a different material that actually means we've got different characteristics from a wear point of view. So there is potentially of looking at this in an additive manufacturing point of view, so we can mill out the actual excavated area and then put some of the material in there that actually has got better wear properties than the base metal it had in the first place. And obviously something like that can be done in a factory environment from as new in future, to be able to actually perhaps have a crossing that's made out of grade 260, but it's got a premium steel perhaps on the actual surface. That means we've got much better characteristics from a wear and batter point of view. So obviously a lot of work's being looked at in terms of modelling for this, and we're going to go through factory acceptance testing for this particular piece of equipment in the next few weeks, to then get that on site within the factory to actually carry out the actual repair development techniques, which is going to be very similar to what we've seen in the DDR process, but clearly you're focusing at AMS type crossings in this case. But looking further then onto additive manufacturing of S&C components, the idea here is really looking at, in this case, reverse engineering of components, because obviously we have lots of different component types that we need to make sure we can actually manufacture if necessary in short-term lead times. And clearly, if it's a bespoke item that's been made for a particular S&C unit that's really just a one-off, the potential is that that item hasn't been required for many, many years since it was installed in track. So going back and trying to find the mold for that might be a challenge. The mold may have been thrown out because perhaps during stock taking people have looked at it and gone, well, it hasn't been used for 30 odd years, so what on earth are we keeping this for? It's never going to be needed. So it's lost. So the beauty of doing this piece of work is actually, you can see in the picture there, we have a guy holding a scanner there, which is just taking a scan of that particular component. You can just about see lots of little white dots on that component and then on the disc that it's sat on. Those white dots are really what the actual scanning is picking up. They're just randomly put onto the component, so it can actually sense in terms of space where it actually is in terms of what the dot is looking at, and that references to the edges of that component, so it can get a scale of where the dots are relative to the edge of the component and make up a 3D image of that, which looks like that. It even gets to the actual get my actual words right, get the content on there. Looking at the side there, you can see there's 3 or 4 marks on the edge of the surface there, which is obviously some damage that's on the component. So actually copied that as far as scanning is concerned, so it's that accurate in terms of what it actually can achieve. So what we can do with this is actually create a 3D CAD file from this particular type of software, and that CAD file can then be used to either additively manufacture a new component in whatever material you like. So it's got all the actual dimension requirements, obviously looks at the shape and get everything exactly the same as what you see in front of you, but clearly on a different scale with different material. Or you could look at it in a different way in terms of looking at creating a mold for that. So in terms of additive manufacturing, you might find that clearly it's a much more expensive process to go through because of the cost implications. But if we're looking to try and actually cast something again in the cast iron, as most of these components in front of us on the screen are, we can create a mold for those. So if you look on the right hand side there, there's a little, well, it's a carburetor, it's only you can see half of it, which is made in plastic on that particular example. That was an example they showed the SolidWorks people who are actually doing this work for us, showed us, which is for a motorcycle carburetor, and it was a very old motorcycle that obviously was way out of production, and there was no way of actually getting a part to replace this carburetor because of the fault it had. So what they did is actually scan it in the way that this scan is showing with this particular piece of equipment, created a 3D printed wax mold, wax copy, sorry, and then they actually made a mold out of that. So then they can actually then recast the actual carburetor in aluminium, which is what they did eventually. So it just gives you a feel of what actually is possible in future, especially where we've got these bespoke items. But obviously there's more to it than just doing reverse engineering. We could look at next generation componentry, which might look at some of the one-offs we might actually need to prototype and work on those to make sure we aren't actually instilling lots of cost for molds to be manufactured, etc. So lots of advantages of doing additive manufacturing and lots of possible potentials for looking at how we use this in our manufacturing base as well. So it's not just a case of maybe we've got a stack full of housings, molds, etc. in our manufacturer's possession that we've really got a big problem with because they've got to be stored somewhere. I'll give you an example. I think in Progress Rail's terms, they obviously make lots of cast manganese crossings for us, and I think they've got about 1.5, 2 warehouses full of different molds for our crossings that we have on the infrastructure. And clearly that's a massive undertaking to store all those, and clearly making sure they've got the right one when we need it. So this is a way of actually getting away from that way of having these stored in different way, looking at storing them in software instead of in a warehouse. Okay, moving on to the handheld scanner for switch rails. Now this is a forerunner really in terms of looking at, well, you may have seen or heard of me talking about the Felix project I'm managing at the moment, which is looking at S&C laser profiling. Well, obviously that machine is going to do lots of profiles, it's going to take lots of data, it needs a possession to go on track, it's got to be taken to site, put on the track, operated, taken off site, etc. So obviously a lot of logistics in terms of using a machine like that to understand whether you've got a problem with your switch rail in terms of derailment hazards. So what we've been looking at as well is something a little bit more versatile that actually can be used to take one snapshot of a switch rail using a laser scanning system to similarly look at whether the actual contact point between the P8 wheel profile and the switch rail gives us a positive or a negative answer. In other words, whether we've got a derailment hazard or not that we need to actually act on. So this has been produced by Abtus. They've been working with the University of Birmingham on this as a project, which University of Birmingham were looking at this from my intervention with them about 3 years ago. They used some PhD students to start developing this. Aptus have taken it now to the next level, where you can see on the right hand side there's a prototype of the item there, and that's obviously something that has been used to create those sort of profiles at the moment. Obviously it's work in progress, so it's just showing the concept as it is at the moment and the potential for it to be able to do exactly what we need in terms of taking one snapshot of a switch rail. So in other words, if a supervisor's walking down the track doing his supervisor inspection of switches and crossings, he sees a switch and he sees some damage on it or some wear that looks a little bit dangerous and he's not quite happy with it, he could use this scanner to assess whether the actual wheel contact point of the P8 profile is going to give a pass or a fail when it comes to the 053 standard checks. So this is what this is going to do, and it clearly takes away the human factors issues that we've been talking about in previous presentations with about the Felix, etc., where this will make the decision as to whether the P8 profile will fail or pass in terms of the contact point on the switch rail. The one thing that we need to be mindful of, though, is obviously if you've got some cant on the switch and crossing, you have to be mindful of what the actual contact with the other rail. In other words, if you've got an axle with two wheels on it, the opposite rail wheel interface will influence the angle that the wheel that's on the switch rail you're trying to measure touches the switch. So there's got to be some compensation in that. And that's a bit of a challenge at the moment that we're looking to try and find a way around. Using algorithms where we possibly can do to make sure that that factor's taken into account. So quite a lot of exciting work going on with that one. And that's obviously something that's going to take further into the next project, IN2TRACK2 which starts in earnest this year, to get this to a point where we've got a prototype we can take out on track and test and make sure we can actually be satisfied it works as we're hoping to. And obviously, if we can get to the point where this is completed, as its researchers actually got to the point where it's proven it's working correctly, then this is something we can supplement in the future in terms of what we can use in maintenance terms. It'll use similar software in terms of what the Felix system is going to use, so we've obviously got comparison within both systems software-wise. Okay, moving further on, we've got the University of Huddersfield looking at a NR56V crossing profile optimization. So if you look at this schematic here, which is showing a little bit about how the optimization of crossing profiles has been developed so far, NR60 Mark II switch and crossing units, which are obviously have been introduced about 3 years ago, were designed in the same way in terms of geometry measurements requirements for the actual switch profile. So in other words, the actual initial design requirements were to optimize the crossing profile of an NR60 Mark II crossing. This has been done using obviously multi-body simulation tools, etc. And we're going through an iteration of actually validating the model that they've actually used for the NR60 Mark II by doing some measurements at the Thirsk site, which was the first site that was installed with NR60 Mark II, to then actually add that validation to the model to make sure that we can optimize the NR56V crossing type. So there's obviously lots of work there looking at those particular tasks that you can see on the screen there to actually get that work done. It's not just a simple cut and paste the optimization process that they used for the NR60 Mark II, because the NR56V is quite different in its profile. But we need to obviously have the same principles as we move forward. And on the right-hand side there, you can see what's going on in terms of work that's been going through this project. So they've obviously looked at some sensing systems on there that Huddersfield have done. I think this was at the training centre in York that they actually put these on to actually see what they can actually find from the sensing system they've got there. Using an S&C mini prof to look at profiles. They've got some data from the Thirsk site. We've got the Felix system up there to do some of the trials that we're actually undertaking with the Felix system to get the profiles of the crossing itself. And that's the sort of data on the right-hand side that the Felix has produced that is being provided to Huddersfield, so they can actually validate the model to then actually optimize the further work in NR56V crossings. So quite a lot of exciting work going on in there to move away from reducing the actual impact damage we see from the wheel rail interface as the wheels move from the wing rail to the crossing nose. So hopefully reducing the loading, the impact loading on the crossing nose, which is what we're seeing on the actual NR60 Mark II crossings, mirroring that on the NR56V, to then hopefully, in terms of doing that, reducing the loading that's actually being imparted on the crossing nose during the wheel transfer, so we can actually extend the crossing life and reduce the amount of maintenance that we need to do and make our crossings more reliable. Switch rail coating. This is something we're looking at again in terms of switch rail wear, trying to understand a little bit more about one particular coating that's in track at the moment in certain locations that's been assessed to see if that's actually given us any benefits to actually reduce switch side wear. We've got the University of Sheffield working on this, and obviously there's quite a few photos there looking at the type of instrumentation they're using out on site to understand what the surface texture, the surface characteristics of the coatings that have been installed in some sites are telling us, and whether the actual coating's actually working or whether it's just actually getting worn away underneath traffic. So this particular coating is an Alphatec coating which we've had in track for a few years now, just to try and actually understand what the performance characteristics of that coating actually is giving us. On the flip side of that, there are other coatings that we're going to get the university to do some testing on to find out, obviously, if there's any other options to look at different types of coatings, what their characteristics are, and whether they're worthwhile actually putting on a switch rail to see if they can actually help in terms of reducing side wear and obviously reducing friction in the same boat. So quite a lot of equipment there that they've actually used on site, which wasn't able to be used before because the portable surface profile and the tribolometer were only fixed assets they had in their lab. There were no portable versions of those up until about the last 12, 24 months. So they've now got these pieces of kit, which means we can go out on site, do these tests without actually having to just rely on what they do in the laboratory. So obviously quite a lot of work going on in that one to see if we can actually improve our performance of our switch rails through adding coatings to them. And finally, looking at monitoring and sensing of an SNC positioning. Now you think, well, okay, what on earth are we doing to do this for? Well, we've got some issues in terms of network rails databases have all been updated to look at feeding into our master database for switches and crossings, which is Ellipse. Unfortunately, we've had lots of legacy systems which have been produced and used over many, many decades. And obviously the data is still valid, but clearly needs to be incorporated into the more modern database, the Ellipse database. But unfortunately, when some of the data has been transferred, they've found out that actually the alignment of the linear positioning of the SNC has not always been able to be matched with each different database. So clearly, when we're doing track recording runs, etc., we can get some disparity between what one database has said, the legacy databases in this case, and what we want to actually, what we've created as a hierarchy and database system in Ellipse to actually look at where exactly is the SNC in terms of linear positioning on the track. So what we're looking into at the moment is looking at potentially having an RFID node on a switch and crossing. So in that sense, it's going to give us definite positions of where the SNC is, so it can actually align everything with the Ellipse database issue with the legacy systems, etc. So we can have one defined position. Now, the problem with this is obviously if you look at SNC in terms of how it's defined as where it actually sits on the track, the definition of old has been, well, the front of the toes of the switch where the first weld is, that's the start of the switch. And then the end of the crossing is where the last through bearer sits. And that's a slightly broad definition that's on the SNC as a plain track turnout unit. But clearly, when it looks at certain areas where we've got complex SNC, especially station ropes, it's clearly not easy to actually use that definition. So what we're looking at here is potentially identifying the crossing nose as one node and the switch toe as the other, as they're the definitive positions which really very rarely move. So we can actually be more confident of actually having a broad linear footage or meterage, if you want, as to where the SNC starts and where the SNC finishes. But obviously it's a little bit vague in terms of, obviously the SNC will go further back past the crossing nose and slightly in front of the switch toes. But those two positions are relatively fixed, so they're quite a key area to look at how we can identify the SNC. So at the moment we're looking to working with the track recording vehicle guys to understand what we can actually put on the vehicle to make sure we can, as far as possible, use the RFID tags for the majority of the speed. So from 5 miles an hour up to 125, and it can still read where the position of the SNC is, which will obviously make a lot of sense when it comes to all the data that the NMT and the other track recording vehicles record. But clearly, if you go on site and you've got an app on your phone, you can actually click on or scan the RFID code, and you can get the information that the ID code can contain or actually send you to. So quite a lot of advantage and potential for using this particular method of identifying the SNC in positioning terms, but it can be expanded to look at linking somebody on site to perhaps maintenance records or design information, that type of thing. So lots of areas where we can actually expand on what we can actually do in this. And lastly, just looking at kinematic systems, you've probably heard of Repoint in the past, where Loughborough University developed the Repoint system initially to have a novel method of actuating point operating kit. Hopefully this video will work. Just show you a bit more about how it is designed, what the concept is, by seeing this movement. So as you can see, that's the idea of moving the position of the full head section of rail, locking it into position, and then obviously just reversing that to show you that actually would move backwards and forwards. So that's the concept for the repoint. So you haven't got cylinder switches in terms of the full system. You have full head section of rail like you've got here, and it just moves from one position to another to link in with another full head section of rail to move the train from one track to another. So obviously that's the concept, and that's what we're trying to actually move further forward in development. So it got to the point where it's actually been developed quite a lot through Loughborough University initially. University of Birmingham are leading this particular piece of work, but Loughborough University are a partner with some of the other partners that were developing this in the first instance, which was, I think a lot of work was done with the RSSB as well to look at how this has developed to the point it's got to now. The reason why Birmingham University are leading this rather than Loughborough is because the professor who was actually in charge of the repoint system now works at Loughborough University. So there's a link there in terms of some of the other staff that moved to Birmingham as well. So that's the reason why that's actually in Birmingham's lead at this moment in time. Oops. So that's the repoint system itself as it was installed at the Grand Central Railway in 2018, I think. And it's just showing you the concept in terms of its visual look. Obviously, three quite large and wide bearers there with all the mechanism inside for lifting the switch up on a conventional switch in this case to move it from one position to another. So this obviously is something that was looked at by quite a lot of engineers within the rail when it was actually available to go and look at. And one of the problems that seemed to be quite high on people's list of things they didn't like about it was the actual width of those bearers. Quite a lot wider than you can see of the concrete equivalents that next to it because of the drive mechanisms that were actually contained in it. So what we're trying to do as part of the work is miniaturize the actual driving mechanisms, the gearbox, the motors, etc., that are in those bearers. And the reason behind that is when we're talking to the repoint people project team in the first place, it's that really they went just to get the biggest they could fit into the bearers to make sure the system would work. So optimizing the actual drive motor, the drive gearbox, and all the linkages inside there is a key thing to try and miniaturize as far as possible, still to give the right performance, but to the size of something like the actual width of a normal bearer, so we can actually maintain it with tampers, etc., as we can now. So obviously quite a few challenges to go through to actually get that done. And looking also at the command and control system, which are the two work streams we're looking at, so the miniaturization and the command and control system itself. So in this case, when it was presented at the Central example here, the command and control system is very, very immature. So there's an awful lot of work to actually develop that and modeling going on to actually look at how that needs to be developed to the point where it could actually be feasibly functioning in a piece of track. So the further work we're looking to do in IN2TRACK2 is to actually take this to a full head section demonstrator where we possibly can, not necessarily in track as we are with this particular one, but if we're able to, then that will be something we'd look to do. But basically looking at the full concept of what Repoint's initial objective was, to have a full head section moving from one position to another to link different rails together. The bigger problem for us at the moment is obviously work to carry out on what that joint looks like when it comes to the joining of the two rails when one moves from one position to another. That work hasn't started yet with the project team. They didn't look at that in terms of where they are now, but there's some work which we're going to get involved with the University of Huddersfield, who've done some modelling on the Repoint system in the past to look at optimising what that joint might look like, and clearly have quite a lot of work to try and optimize that so we don't get the failure modes that might introduce to some system like this. So ultimately, if we can develop this into a situation where we've got a potential concept that can be made into a prototype to show how it could work within a physical infrastructure location like this. So all I've got to go through. There's obviously a lot of other projects that Melanie and myself haven't talked about, but this will hopefully give you a flavour of what type of work we're doing within the IN2TRACK2 project from a network perspective. Thank you very much. So has anybody got any questions?
Thanks, Phil, and thanks, Melanie. Go on, Kevin.
Yeah, I have a number of questions that have been raised. First one is from Steve Featherstone. I recall railhead repairs being approved about 10 years ago. What is the utilisation of this as an existing approved technique before we seek to build a variant solution?
Melanie, do you want to take that one?
Yeah, sorry, just coming off mute there. Yeah, I wonder if this is the gauge corner restoration machine that Steve is talking about, because
no, it's not, Melanie. Yeah, we developed a technique where for the same sort of railhead issues that you've got, we sort of sculpted out the defect, and then we dropped a weld into it, and then we ground it off back to the rail profile.
The BV1000?
No, the BV1000 was for. That's my next questions about the BV1000. That was about the crossing repairs. Oh, yeah. This was a railhead repair using a thermite weld, and as far as I'm aware, I don't think the utilization is as high. But I don't have any data, and I think the reason was it was all around access time and speed, and it was cheaper to cut in a new section of rail than it was to use the equipment, and time was all precious.
Yeah, okay. I'd need to look at that, but the reason I asked the initial question was that this. About that time is when this particular piece of equipment or development started. So obviously they started at very similar times. So because this has actually gone through, although I said it was Interrail, it started in Interrail. Actually, it was prior to that. But it was a development of the gauge corner restoration machine, and it has got, and so this particular piece of equipment has sort of gone through, started on Interrail, and then was also involved in a UK project as well. So it has actually sort of been developed over that sort of time frame. But yeah, I would certainly look into that.
Thank you.
I've got a question from Andy Savage. Would drone survey of S&C have sufficient focus to have picked up the stretcher bar failures at Greyrig?
In short, yes. They've got a great deal of but the actual footage that you can see, I only showed you a snapshot really of what it's actually capable of, but from even 35 meters up, you would have seen the cracks in the stretcher bars. It's that good.
Then carrying on from Justin Lewis about S&C and drone inspection, we have an NR60G switch as a test bed for a new to the UK POE system in an off-track position in Wellingborough. Would this site benefit you in developing the drone surveying of points? The site only has the switch panel, no crossing. Yeah,
that'd be certainly we would definitely look at that as a possibility, because clearly it's quite a long switch by the sound of things. So that would certainly have some help, yeah, at Wellingborough.
So in that case, then, if you two would like to get together.
Yeah, if you don't mind dropping me an email just with the detail on that, would be helpful. I can make contact with you. Thank you.
Is that all right, Justin? Okay, right.
Yeah, that's fine. Thank you.
Okay, and then as mentioned in passing from the first one in relation to Steve Featherstone, I recall that we developed and approved crossing repair techniques about 10 years ago. Unfortunately, access time means that crossings are generally changed rather than repaired in situ. They are, however, repaired back at Whitemoor and then reissued. Will the same be the case for S&C switch rail repairs, namely that they will be replaced and then sent to Whitemoor for repair and then reissue?
Yeah, just on obviously quite a few questions there. Yeah, Whitemoor, I've been working with them on something slightly different, which I'll talk about in a moment, but they have a very poor take-up on refurbished crossings, mainly down to the fact, especially with AMS, they can't give the ultrasonic green light that there's no defects in there that they haven't found. So obviously routes can be a bit wary about taking those, because they're thinking that if they put one of the refurbished crossings in, probably a high-speed line, for example, if it goes wrong because there's a defect in it, there's obviously a shot in the foot slightly in terms of their viewpoint, because obviously it's going to mean more work and more expense to get another crossing. So there is some other work which I'm looking at to do with ultrasonic testing on cast manganese crossings, which is something else that's slightly outside of this particular infrastructure project in IN2TRACK2. But effectively what we're trying to do with this is obviously the BV1000, if that's what Steve's referring to when it comes to the repairing process. Yeah, obviously that wasn't rolled out very well in terms of its uptake, and obviously there's still a bit questionable about how many people are actually physically using it and making sure they get the advantage of it. The advantage of this one obviously is actually doing quite a extensive excavation to try and actually make sure we can weld repair the wing ray and the crossing nose at the same time. Clearly, I've heard of horror stories where welding teams have gone out and they've only had time to do one or the other, and then have to come back the next weekend perhaps to finish off the job by doing the bit that they've not actually managed to repair. But in the meantime, we've probably created a bigger defect for us, because we've actually got a huge height difference between the repaired part and the bit that needs repairing. So this is automated, so it's moving away from the semi-automatic process that the BV1000 has got, being fully automated in terms of its excavation, deposition of weld repair, and then milling, and actually getting the profile correct by using a similar process to what was shown on the DDR machine. So it's going to be looked at in terms of milling to repair the crossing, reprofile the crossing, sorry, and then it's going to actually be reprofiled. Sorry, not reprofiled, it's going to be checked after it's been reprofiled that the profile is correct. So in other words, using some sort of laser profiling system to confirm we've got the correct profile afterwards. So it's moving away from any intervention human-wise that will obviously give us some potential issues that might mean that things are not going quite as well as they would do if they were all perfectly automated. And the automation is the bigger advantage here, that we're actually getting that process done without any human intervention. Hope that answers the question.
I have a number here. I don't know whether we'll be able to get through these all within the time. If we can't get through them, I will arrange for them to be passed on to the presenters, and then hopefully we can then get back to those particular people subsequently with the answers that they give. Another one from Andy Savage: is the reverse engineering of cast components economic for single components? I'm thinking of casting for heritage lines such as the Festiniog, where a lot of the patterns have been lost but components survive. What is the minimum economic production run?
I don't know the answer to the minimum economic production run. I can't answer that, unfortunately. But I think in terms of being able to have the capability of recreating that component is obviously what's needed. Clearly, if it's a case where it needs to go away, be taken away and the molds recreated, etc., then obviously there's quite a lot of lead time in there. And I think the beauty of this was actually being able to take a copy of the component as it is now. If you need to adjust it because of wear, etc., to actually make it more appropriate to what it was perhaps when it was new, that can be done on the software side of things to actually improve its characteristics before you get a copy of it. But I think the advantage really was the capability of being able to actually get another copy of that component in terms of lead time, but also if you needed to have something that was set up for other potential requirements, in other words, needing more than one of those components, you could create the 3D printed version of the molds, so actually use those. So economically, yes, it can be quite expensive when it comes to additive manufacturing of a component, and clearly cost against advantages obviously is something we'd have to weigh up. For a heritage line, it might actually be a cheaper option, it might not, depends on the circumstances, because clearly for heritage lines, cost is clearly a big factor of repairing anything. So I'm giving a bit of a woolly answer, but effectively, I think in terms of being able to do additive manufacturing, it gives you the option actually of creating a copy of that component, which is obviously something that can be done a lot quicker than going to a casting company and asking for a mold to be made, which obviously is very expensive, and then clearly having the actual component made in the traditional way.
And then following up on that one, Franklin Dokwan has asked, it's interesting that NR are looking into reverse engineering. Have you looked at PowerShape Pro that provides the most comprehensive range of design techniques available in a single CAD program, which is a combination of solid surface and direct molding and is good for reverse engineering for bespoke components?
No, it's not a process or a software package I'm aware of. Actually, we're working with SolidWorks, basically down to the fact we have a license and we have a capability of one of our engineers actually manipulating and using the CAD software that they're actually providing for us. So clearly the link there is more beneficial to us because we already have the capability in-house to do the work with the SolidWorks software. But clearly, if there's other software packages that might give a better result for this from additive manufacturing's point of view, then clearly, yeah, we need to consider what they might actually bring to the party.
Question from David Webb. Phil, will we be developing a decision support to enable us to predict and prevent failure relating to switch and crossing profiles?
Yeah, it's something I'm working with asset information within Network Rail at the moment to look at all the data that we can get off the Felix system in particular in this case, to do the data analytics and obviously look at what new information is coming off the machine that we need to be able to have available for our maintenance staff to use, and obviously anyone else that needs to get access to it. So clearly, yes, the performance of the profile data and how it's going to be used and stored, etc., is something that asset information and myself are looking at how we can use that information effectively and obviously make sure it's available to everyone that needs to access it.
And then from David Holmes, would the drone be able to fly at the low altitude required in the built-up area, where I believe CAA rules a minimum altitude of 500 foot?
Yeah, we have to obviously comply with CAA regulations, but with the airspace above the railway, it's Network Rail's airspace. So we have obviously certain characteristics of the flying heights we can actually work at, depending on whereabouts it is in the country, whether it's in the built-up area or not. I'm not quite sure what the actual minimum height is that I've been quoted by Plough and Craven, but it might be 35 meters, which is why we use that figure in terms of the trials that we've done so far. But yeah, there is a factor there that we need to obviously make sure we put into the actual mix when it comes to putting the process together. But yeah, the CAA regulations, I'm basically looking at Plough and Craven to assist me on that, to tell me what I need to actually comply with so we can put the process together to meet all those requirements. So yeah, clearly is something we are working with. But I think 500 meters is something we can actually use differently in terms of what we have in relation to airspace above the railway.
I have a question now from Stephen Barber. The NR work on switch rail scanning looks very interesting. Have you made any use of trials of the Craw track scan rail profile manual measuring trolley, which appears to be an established product?
Craw, somebody asked me this the other day actually, whether we were looking at the Craw system. The system I looked at, when we looked at trying to S&C our profile S&Cs with the systems that were out there, the problem we had with the Graw system was it only did one rail. And at the same time, the Felix system was being developed by Lucioni, and that can do both rails at the same time, simultaneously, obviously. And the advantage of using the Felix over and above the Graw system was more in keeping where we wanted to actually take things forward in terms of 053 checks in particular. But there is, I think somebody's trying to put the Graw system through product acceptance with Network Rail at the moment. So there's obviously a link in there in terms of profiling and clearly the data that comes off those machines as to how that's actually going to be used. But we're obviously there's another system that Graw have got, which is a Scorpion, which looks at crossing profiles and doing 3D scans of those, which is something else that is linking into some of the work that looks at crossing maintenance, just as a sideline.
Peter Halliwell has then also asked, in locating switch tips and crossing nose tips, how does linear track position relate to the fixing the location in 3-point coordinate geometry?
You're asking somebody who doesn't know the answer to that one. That's a bit more complicated than me. I will refer you to my university colleagues who can probably tell me that one.
Stuart Corrie, do you have any thoughts about how to deal with novel problems occurring in areas where the inspection and maintenance is autonomous?
There's lots of issues with autonomous inspection that obviously are going to have to be assessed in terms of what's the usability of them. Are we actually going to increase or import different risks that we don't currently have to manage at the moment? And if so, how are we going to manage those? Lots of things, and even it's going to come down to obviously our colleagues that are actually doing inspection at the moment will be a bit fearful about actually take me out of my job. So there's obviously all those large sphere of issues that we need to address to make sure that we aren't actually forgetting any particular aspect of it. So I think in terms of different locations for doing autonomous inspection, it's going to have to be looked at across the piece. For example, if we wanted to use drones on plain line track, at the moment there are some regulations that mean you can't use a drone that's flies out of sight. So in other words, if we're walking a 5-mile section currently in BVI terms, using a drone to fly 5 miles of track and the drone's actually out of sight of the operator, we can't do that yet. It's work to try and look at how it can actually be achieved and get in CAA regulations to allow us to do that.
I think that's a CAA requirement.
It is, yeah. And that's obviously something that I think it's not just our industry, but other industries who need, like power lines, for example, who need to inspect in terms of large linear distances. There's an issue there that needs some sort of legislation that allows that to happen. But clearly, work's going on in the background, clearly with CAA to actually look at how that can be done.
Now, in that case, then there were a couple more others, but I think they were all wrapped up inside some of the others. So if I can ask John Edgley.
Here I am. Okay, thank you very much, Kevin, and thank you very much, Phil and Melanie. That was an extremely interesting dive into the RD&T that Network Rail's carrying out, and as you know, that I've got a certain skin in the game with that, so I'm delighted you put it across so well, and the engagement we had from everybody here. Just a quick couple of thoughts, really. That it's quite clear in the environment and the place that we find ourselves in. I was going to say post-COVID, but we're just coming out and emerging from COVID now. That it's quite clear RD&T, if nothing else, is more relevant than ever, because what it will do is will help us find better ways of doing what we already do, especially if we can do it more safely, more efficiently, to help improve and maintain performance, but also cheaply, effectively as well. So hugely important for us. There's a couple of my favorites in there, and I'll just sort of share them. And that is the rail stress measurement that Melanie mentioned. If we can actually get that without in a non-destructive way, that for me is the holy grail of track maintenance. So I've got my fingers crossed and hopes are very high for that. I'm also a big fan of track stiffness measurement because I see that having huge opportunities for the whole of the railway industry to actually identify problems before they actually become real issues which cause safety or performance challenges. And quite clearly, there's quite a lot of engagement about the additive manufacturing opportunity. So I think we're heading in the right direction. We really need to pull together as an industry and get these things across the line as quickly and effectively and efficiently as possible. So I think at that point, I'll just say to Melanie and Phil, thank you. Your work is crucial to our future. And Kevin, I'm going to hand back to you. I won't do any of the presidential stuff, but maybe next time if I can have 5 minutes. So that's it.
Well, in that case then,